I appreciate the opportunity to give this presentation. I am Yukai Chen from National Formosa University, 湖北科技大学. The title is Design and Implementation of a Whole Body Vertical Vibration System with High Power Factor. The members of the research team include Professor Song, Mr. Zhang, Mr. Chen, and Mr. Chou. The system had two variables that can be adjusted, frequency and amplitude. Controlling the vibrations frequency and the voltage amplitude can determine the parts of the body that vibrate. Therefore, the whole body vertical vibrations can be said to be present physical activity. The function and the advantage of vertical vibration include increasing muscle strength, bone density, and accelerating training. The main purpose of vertical vibration are as follows. The first point is control the amplitude and the frequency and under the impact of low ground reaction force. For example, the vibration's amplitude of 3 mm, the frequency of 3 to 13 Hz. The generated ground reaction force impact is 0.05 G to 0.91 G, which is relatively safe and will not increase cardiopulmonary load. The second point is the vibration frequency is 2 to 6 times higher than that of active exercise. The total amount of vibration stimulation per unit time is much higher than that of active walking, jogging, and fast running. The use of electromagnetic coils in vertical vibration machine is the main development trend at present. It can increase its structural stability to avoid damage under long-term use. In this research, we use digital full-bridge converter with microcontroller to replace analog Class D amplifier, which can increase the feasibilities of the system and the future relative applications. Additionally, the system uses a switching power supply to increase its circuit efficiency, and the power factor collector can increase the power quality. High quality and low cost are important considerations in this research. Input voltage of the vibration system is 110 volt or 220 volt. Output voltage is from 0 volt to 68 volt, and the output frequency is 3 to 70 Hz for electromagnetic coil. The switching mode power supply consists of two power stages, a AC to DC converter for power factor collector, and a PWM-controlled DC to DC converter configured as a two-transistor forward topology. The PFC stage is a step-up converter, which serves to provide a 380 volt DC bus at its output while consuming sinusoidal line current at the input. The two-switch forward converter provides isolation from the AC line. There are two output voltages, 96 volt and 12 volt. A full-bridge single-phase inverter is a switching device that generates a sinusoidal wave AC output voltage with SPWM, the control method. The physical circuit is shown here with PFC and the two switches forward converter on the left and the full bridge converter on the right. The detailed specification of AC to DC converter and the DC to AC converter are shown here. We can see that the power rating of the vibration system is 300 watts. The major input current and the voltage waveform are shown here. From this waveform, we can see that when the system works at 110 volt and 220 volt, the input current and the voltage are in phase and close to sine wave. Therefore, the power factor of the circuit is close to unit. The major AC to DC circuit efficiency curve is shown in this figure. When the vibration system is operated at input voltage is equal to 220 volt and the load is equal to 360 watt, the maximum efficiency is 90%. The system has two variables that can be adjusted, frequency and amplitude. This figure shows the major waveforms of the output voltage at different frequency and amplitude. This is the control interface, the vibration platform for experimental testing. The final product sold is a whole body vibration machine branded by SONIS Sonics. Finally, let's take a look at the video of the research results.